Hello and welcome to ArcGIS REST JS. I'm Dave Bowman and I'll be doing the first part of this presentation. And today we're going to be talking about using ArcGIS REST JS to work with users, groups, items, and feature services, basically the portal API, if you will. So let's start at the beginning. What is ArcGIS REST JS? Well, it's a series of packages that are written in TypeScript that form wrappers over our platform REST APIs. This enables a wide variety of different things to be done. So from platform search for items, for users, for groups, we streamline the authentication process and take a lot of the intermediate steps out of doing OAuth or just token-based authentication. We give you functions that allow you to create, remove, update items, groups, and services. We also give you those same sort of functions for working with the features and the rows in tables or feature services that are hosted, as well as working with item sharing, sharing items between groups and taking them away. ArcGIS REST JS is also an entry point for using the new pay-as-you-go services. So this was stuff that was released as part of the ArcGIS REST JS 3.0 release in kind of the middle of January. And this allows you to do kind of, use an API key and start using location services, geocoding, and demographics. So that's a new feature. That's not what we're going to be focusing on today. In my part of the talk, I'm going to be talking about the project background and philosophy and kind of what it's like to work with this API. And then the second half of it, we're going to be, Tom Wason is going to be showing what it's like to actually work with using items and groups and those sorts of things. So the goals for the REST.js project really were to design and develop a consistent JavaScript API that we can use in Node and in modern browsers. What we found is even within Esri, there's a wide number of teams that are building various different applications using JavaScript. And many of them were building and rebuilding similar types of functionalities without using the JSAPI directly. And so a number of us got together literally at the developer summit and said, hey, we should work together, right? Instead of everybody creating their own partial implementation of things, some that worked in Node and some that didn't, why don't we just get together, do this right, do it once, and then everybody can use it. And we'll do it open source, and that'll be fantastic. We wanted it also to be a la carte, a very lightweight thing. So you install just the packages that you need. We also didn't want to drag any frameworks into this. So it doesn't rely on Dojo, it doesn't rely on Lodash, jQuery, none of that stuff. Even though it's written in TypeScript, it compiles down into ES5 or CommonJS for our Node. We wanted to have a consistent kind of API that would hide the underlying HTTP API idiosyncrasies. So even though the API returns errors with a 200 code, when you're using REST.js, that error will cause an exception and it'll be thrown. And so it'll kind of have a better alignment with the broader JavaScript ecosystem in that way, as well as just being something, that works the same way as most other packages will. You're going to npm install it. It's written in TypeScript, so you've got types. If you don't want to use that, that's great. You can, write it with vanilla JavaScript. You can use require.js, all these different things, right? Very consistent, very just kind of down the middle sort of the library. In terms of functionality, one way to think of it is it's kind of analogous to the ArcGIS API for Python, although that API tends to focus on geoprocessing. And REST.js currently is much more focused on just working with the platform entities. So your portal, the users, the groups, the items, the feature services, and that sort of stuff. It is also extremely different from the ArcGIS API for JavaScript. One way is that there are no components. There are no visual elements to this at all, and that includes no map, right? And we're not going to build a map for this. The Esri JavaScript API is the official kind of map-based one. It's also open source, as I kind of mentioned this before, which is pretty cool. You can see all the code, that's great. You can see what might be wrong. You can submit pull requests, so on and so forth. It's on GitHub in the Esri organization, ArcGIS REST JS. We've got a number of different contributors. We've got, well over 50 forks. We've got lots of different people that are contributing stuff to it. What's important about it being open source is that if you need something, or there happens to be some part of some REST API that we don't have covered yet, go ahead and open an issue and ask, or better yet, submit a PR. What's pretty cool about this library is that it is most of the functions are very, very simple. It's construct a URL and use some tokenization, make sure the item ID goes in the right place, and delegate off to the request function. And the request function, that's where we fold in all the authentication and we handle tokens and we handle federation and all that stuff. So for the most part, actually extending this is very simple. And that's why we've had so many people who've actually made contributions to it. Another thing about the repo, this is a pretty common structure at this point, but it may be new to some people, and that is that it's called a mono repo. So even though there is a single repository, inside of it, there are 9 packages that we actually ship. And those are packages that you can install independently. So those 9 packages, first and foremost, we have request. There's an awful lot of logic in here that actually handles making sure, when do we do a get, when do we do a post? Do we have to force a post on certain requests just because of the way the API works? How do we send tokens, which can vary based on different APIs, so on and so forth? And how do we handle errors when they happen on, we get an error back from the server? How do we bubble that back up? So the request module is used by virtually everything else. Auth is also very broadly used. That's really where your user session lives and all the functions around handling OAuth. And then we have portal. So that package contains everything to do with users, groups, items, sharing, and the actual portal object itself, managing your portal, that sort of thing. Routing, geocoder, and demographics, these are kind of the libraries that are the a la carte, just use an API key, do some routing, whatever you want. You can, of course, use all 3 of those packages with a named user as well. But that's just kind of the new area of the application API layer. We have the feature layer, which is how do you work with the features or rows in tables that are in hosted feature services. And then we have the service admin. And so this allows you to create feature services, add tables to it, add views, so on and so forth, all that sort of thing. So that covers an awful lot of the portal API surface. I want to talk a little bit about the documentation. This is hosted on GH Pages, GitHub.io, ArcGIS REST JS. It's a pretty standard format, kind of looking help documentation. We've got the packages in a tree view. So let's open up a package. The main one that we're going to be talking about today is the portal package. We can see all the functions that are in there. And then on the right-hand side, obviously, hey, here's the function called getItem. This is one of the most commonly used functions. Hey, go, given an item ID, go get me the item. Optional authentication. So if it's not a public item, you'll be able to pass in your auth and then, get the secured item back. And then below that, right, here's all the parameters. And this is a pretty, straightforward thing to use. It's not super complicated. But the interesting thing I think about the doc is this is all auto-generated, right? This is pretty common, I think, these days. When you're writing code, you can use structured documentation. In this case, it's basically a variant of the JS doc format called TS-doc for TypeScript. And you can see the example that we just showed in this last page, previous slide, is coming directly out of the source code. So that is pretty cool. Every time that we do a release, automatically connected into that release system, the documentation gets updated and re-released. So very automated backend systems around this project, and everything stays up to date. We have a number of guides that are built right into the documentation site, and then there are also new guides that live at developers.arcgis.com. Those are mainly focused on that self-service mapping and the location services stuff. In terms of, should you use this product or project, we've got 100% code coverage. So at the very least, you should feel pretty confident that the code is not regressing. right? It doesn't necessarily change. We follow strict semantic versioning. So if we do need to do a breaking change, we will make it a major release. So that's pretty good. You're not going to be surprised by a breaking change in like a patch release, right? There's 3 or 4 of us that stay on top of making sure that this is following semantic release pretty tightly. The code coverage is actually verified directly within the pull request. So if you submit a pull request and you don't have 100% coverage, then the code cover report is going to let everybody know, and we will not merge it if it doesn't actually have the coverage. What's in the box, you might want to ask, right? How do you get it? Well, it's, as I mentioned before, right? This is an npm install type situation. You can use yarn, doesn't really matter. Everything lives under that Esri organization in npm, and in this case, installing ArcGIS REST request. When you install that, you're going to get ES6 modules. You're going to get UMD. So that's if you're using require, or you just want to, put the script tag in a page. As well, if you want to use kind of older Node, you can use CommonJS. If you're using newer Node or using TS Node, so you're doing TypeScript in Node, then you can use the ES6 modules. So I think we've covered kind of pretty much the entire JavaScript ecosystem in terms of like our build output and what actually gets shipped, which takes us to being used in production, right? This is not just a project that we decided to build kind of willy-nilly. We need it and we use it and we lean into it very heavily, right? ArcGIS Hub, which is the team that Tom and I are on, we use it pretty much almost exclusively. There are maps in certain places in Hub, and those use the JSAPI, but the vast majority of our interaction with the platform is done through REST JS. Story Maps is leveraging this, Experience Builder is, ArcGIS Urban, Solutions, which is kind of a newer thing, which is really the automation of taking a whole set of interconnected items, being able to turn that whole thing into a template and then redeploy it into another organization. That is entirely based on REST.js. Enterprise Sites is, of course, and then we've got professional services, Esri UK, our startup team. Many of our partners are leaning in pretty hard. If you need to build something that's not heavily based on a map, you want it to be super lightweight and really fast, this is really the library for you. Also wanted to talk about the philosophy, because this is a little bit of a guiding idea behind the project, and it kind of bubbles up in terms of how you actually work with the system itself. So not surprisingly, mobile is a big deal, right? This year, ArcGIS Hub, we're only as a product, I think we're 3 years old, but this year we crossed over 50% of our sessions are from mobile devices, small form factor mobile devices. And what's important in that environment, there's 2 things that are very important, both of which lead to this next thing is, right, you really want to have a small payload. And there's 2 reasons for that. One is if you're on a cellular network, well, the smaller the amount of data that has to transit the wire, or non-wire, right, has to transit the network, the better. And then once it actually gets into the device, right, the less JavaScript it needs to parse and run, it's going to run faster, right? Not everybody has an iPhone 11. So if you want to have a really broad access by many people, then you want to make sure that it's still going to work on an older Android device. And so smaller payloads help with all of these things. So REST.js, as we said, is broken into like 9 different packages that you want to work with. But these are the kind of sizes we're talking about. This is a few kilobytes per package. Service admin is less than a kilobyte. And that package, it requires request and auth, but that package is everything you need to work with creating views and tables and those sorts of things. The stuff from the location services, right? These things are also really small. So if you were to literally include absolutely every function in every package, it would increase your payload size by 22.4 kilobytes. Now, if your application is actually using every function in every package, it's going to be an order of magnitude bigger than this, because obviously all the UI, in order to actually leverage all that stuff, is going to take up a whole bunch of just payload. So how is it that we are able to build something that's really, really small and do it in such a way that you as a developer probably is going to get, just a few kilobytes added into your application? You build a big app, well, it's going to be a little bit bigger, but to build a relatively straightforward app, maybe you're adding very, very little, because it's not like request you need the whole package. You probably only need some of the functions in there. And that's really the secret, is that everything is functions in these libraries. And we mean that, right? These packages, if you install them, all you get are functions. And the reason behind this, to get into that, I want to start by talking about how things would be different if we decided to do this using an object-oriented approach where everything is an object. We could do something about maybe say, well, the entry point to this would be like a portal class. And we could write code that's kind of like this: import portal from ArcGIS portal, instantiate a new one, issue a search, and then we get some results back and we work with that. Now, I think most people would be like, hey, that seems pretty straightforward, right? That's pretty direct, pretty obvious what's going on. And this works pretty well in Python. This is very akin to how the Python API works structurally. But the difference is we don't run the Python API on our phones, right? So there's a little bit of a hiccup here. There's an exception, or maybe a problem. And that would be that if we did it from the approach of having a portal object, well, the portal object is going to have more than just search on it, right? That portal class, well, it's going to be kind of structured something like this. It's a class, so it'll have a constructor, and then it's going to have a bunch of methods on it. Not just 3 methods, but given all the things you can do with a portal, maybe like 40 or 50 methods. And these different methods, they're going to return instances of other objects. So when we do a search and we get items back, well, those are going to be instances of items. And those items, as we look at the kind of the portal information model, well, those items, they're owned by users. So you kind of have some sort of an instance of a user, and then the items are shared to groups, and those groups are part of an organization, and then the user can be a member of multiple groups. And you can see that all these different things, they connect to each other. And if you do an object-oriented model and you have to have the ability to kind of traverse from an item to the group, to the members of the group, to the items that those members own, that sort of a thing, very quickly, everything gets connected to everything else. This is great, of course, if your application literally is doing all those things. Like if you're building the ArcGIS online home app, that's going to allow you to basically traverse all these different things. Well, okay, that's not a bad model. But again, remember, we're trying to optimize this library for running on a mobile device and running over a 3G, 4G network. So if you are building a more focused application and you want just 1 or 2 of these methods, right, it becomes much more problematic to kind of detangle those. And this has actually got a name. It's called the banana and gorilla problem. And for the example, you want the banana. In this case, it's the search function, right? And you end up getting the gorilla that was holding the banana. So in this case, it would be the portal class. And then you get the rest of the jungle, which is every other thing that's connected in that object model. And so this quote is from Joe Armstrong. He's the author of Coders at Work, a very good book just about kind of software engineering and that sort of a thing, like, what it's like to be a software engineer through your career. He's also the creator of Erlang, which is a functional programming language that was designed from the ground up to be super, super resilient. And it's used in telephone switching systems. So even though your wireless connection may drop, the actual switching system, it's not like you get connected from one call to a different call with someone else in the middle of your calls on any sort of a regular basis. So anyways, something to check out. Erlang, pretty cool. It's also what powers WhatsApp. Fantastic and really cool environment, but kind of not exactly connected to REST.js. So let's talk about functions a little bit. Functions, hooray! The idea behind writing stuff in a functional style is that every function is independent of every other function, right? They may call each other, there may be a call chain, but you don't have any global state. You don't have state that's shared. You don't have functions that are mutating objects, that sort of a thing. A function has inputs and it has outputs. And if you give it the same inputs today and you give it the same inputs tomorrow, the output is going to be exactly the same, right? They're easy to test. They're easy to kind of think about. They're very simple to use. You import them from the library. And then pretty much any build system today is going to be smart enough to be able to figure out like, oh, you called this function, that function calls the next one, calls the next one. This is the entirety of what I need to actually package up. And that's how you get a super small build. There are some very nascent work on Webpack that is facilitating doing this activity, which is commonly called tree shaking or dead code removal when using object-oriented libraries, but that stuff is not nearly as robust, and it tends to require very strict coding styles. You can't call functions by using names and parentheses as strings and that sort of stuff because the compiler can't walk that tree and figure it out, right? You have to call everything by a dot method. Anyways, if all of this just functional style is just too much for you, what's great is this is an open source library, and you're more than welcome to go ahead and compose some classes out of this stuff. People could create that API, the portal API. And there was some thinking at the beginning of this project when we started like 3 years ago, yeah, maybe some teams will actually do this. But to date, nobody's really taken it up because once you start working with it, it's actually really nice because it's super composable. You pull in just the functions that you need, you string them together the way you want, and you go on about your life. And it's really simple and straightforward. It's also very in line with React, which a lot of our teams are now using, right? A functional style approach. If you were to do this, I would recommend checking out this book called Composing Software by Eric Elliott. He's an interesting author because he is very into functional style programming, but then also looks at the world from the perspective of there are many times where composing a bunch of functions into a set of objects and classes and having a class model that can be really valuable. So it's a very good book. And if you don't want to read the book, you can also just look for Eric Elliott on Medium. And almost the entire book is there as a series of blog posts. So that's really, my section of this talk was the background, the philosophy. Hopefully you take a chance and jump on in and start using this. And with that, I'm going to turn it over to Tom Wason, who is going to show us some demos.
Thanks, Dave. I'm going to try and bring some of those lofty concepts back down to earth through discussion of a few demos. We have a folder in the ArcGIS REST JS repository called Demos. There's 15 working projects in there. These cover just about all of the REST.js packages, and there's Node demos, there's browser demos, and this is a great place to go to find if you're trying to figure out how to do a specific thing with REST.js that might be covered in here. A lot of these demos deal with auth, and honestly, auth is the most complicated thing in REST.js. A lot of the other functionality is pretty straightforward. There's a function called getItem. You pass it an ID, it fetches the item for you. But auth can be a little tricky. We're going to start by looking at browser auth specifically. The ArcGIS platform has many ways to do auth. The REST.js should work with all of them. When we're talking about working with the portal API, quite often, especially in a browser, we're going to be quite often working with OAuth. If your portal is ArcGIS Online, you're most certainly going to be working with OAuth. So that's the most common one we use in our applications. The way the OAuth flow works is that your browser application sends the user over to the portal to enter their credentials there. That way, those credentials are safe. Your application doesn't have access to them. Once they've been authorized, the portal redirects the user over back to your application with a token that your application can use on behalf of that user. It's not just for working with the portal API. If you are working with geoservices or if you're querying features, those servers can be federated to a portal and use tokens from the portal. And RestJS handles all of that for you. So let's look at the APIs, the RestJS APIs that you'll be using when you're doing authorization and authentication. These are all located in a package called auth, REST auth. And when you're dealing with named users, it is a user session is the class that you'll be working with. We're going to look at it, one of those demos that's there underneath the repo. It's called the browser OAuth 2 demo, and we'll just see how that works in action now. Now, when you're doing OAuth from an application, you need to first register that application with the platform. And what you get is what is known as a client ID. And that client ID is associated with certain URLs that are allowed to use it. So we've already done that in this case. When you run this demo on your own, you're going to need to get your own client ID. So the demo asks for you to put a client ID here. Typically, this is something that you would just embed in your JavaScript code instead of having here in a form. And once you have the client ID, you can click the sign in, one of these two sign in buttons. OAuth can happen either via pop-up or by a reload by redirecting your entire page over to the platform. In this case, we're going to use the pop-up, and we'll sign in. And now that I'm signed in, I can see my username down here in this message, and then we click the sign out button. So what does the code look like for this? Well, there's really two steps. When someone clicks that sign in button, we're going to call this begin OAuth 2 static method of the user session class. And that's going to take in our client ID and a URL that we want to redirect to. And in this case, we're going to redirect to an authenticate HTML file that's a peer to this index folder. And this is the handler for the pop-up button, so we're passing pop-up true. You could also, if you don't pass that, then it will do the redirect without a pop-up. And when you use pop-up, the good thing about using pop-up is that your whole page doesn't have to reload. You can keep the state there on that page. You won't lose any state. And so when you use pop-up, you're going to want to handle this returns a promise. You want to handle that promise. The promise resolves with the new user session instance of the user session class that you're going to use. So here we're logging that session, and then we are displaying the username. So what happens in that authenticate page? Well, this is just a really small HTML page, and it's got a really minimum amount of JavaScript on it that needs to just parse the information returned from the portal that's in the URL, and then it calls this user session complete OAuth 2. So there's just two steps. You begin OAuth 2, and then you complete OAuth 2, passing in that client ID. And now, in order to get the session back to the parent page, in this case, or in order to preserve the session, we are storing it in local storage for this application. That way, when you reload the page, you'll stay logged in. You don't have to use local storage. You can use cookies. This part's entirely up to you. So I want to talk about using RestJS in conjunction with the ArcGIS API for JavaScript. Dave talked about the differences between these two libraries, and the way that is helpful for me to think about it is as a Venn diagram. They have some shared functionality, and then they have much more functionality that exists only in the ArcGIS API for JavaScript, and as Dave said, stuff that we are never going to implement in RestJS. And I wanted to show a demo here that comes from, it's not in our demos folder. It is it's a RestJS port of an ArcGIS Online for JavaScript sample page. And the reason I like showing this demo is because it exists entirely in that area of overlap of the Venn diagram. So here's the sample page itself, and the best way to understand what it does is to view it live. When you go and you initially hit the sample, all you see is this sign in button. Click that, going to ask you to sign in. It's doing the OAuth flow. And then when you come back to the page, it shows the list of items that you have as thumbnails. Same thing here. So now here we're looking at the REST.js port of this page. I'm going to sign in. It's going to do exactly the same workflow and give me exactly the same result. One thing to think about when you're comparing these things, we're allowed to see this. The great news about this is we're allowed to see apples to apples, and really you're writing the exact same amount of code. So here's the diff between the two versions. You're writing the same number of lines of code. The reason that you would even bother with using REST.js for this scenario, to understand that, what you have to do is take a look at the network tab. So when we sign out here, this is the ArcGIS API for JavaScript version. When we sign out, it's going to reload the page, and if we filter for the JavaScript that comes in, we see that we've loaded 260 kilobytes of JavaScript just to show this sign-in link. Do the same thing over here with REST.js, and we'll open the network tab, reload it, and we've now loaded 11 kilobytes of JavaScript. So you can see the difference there, right? This is a pretty significant difference. And if the entirety of your application's functionality exists in that this little area of overlap on this Venn diagram, REST.js would be a good choice. But probably for most of us, we need that mapping capability that ArcGIS API for JavaScript too. So what we're going to show you is that there's actually a pretty common pattern where you would still use REST.js in conjunction with the ArcGIS API, and that is when the map isn't the first thing you show to a user. It comes some point later in your application, but from the beginning and the get-go, you still need to do work with the platform. Maybe you need to fetch the app's item, or maybe you need to log the user in. In this case, you can bundle REST.js with that initial payload, and it's going to make sure that your page loading speed is not really impacted too much. And then later on, when you need to use the ArcGIS API for JavaScript, you can lazy load that library, and then you will get all the power of the ArcGIS for JavaScript API, all the mapping capabilities that you need. This is a workflow that we use with Hub. This is the same workflow that Dave mentioned other products like Story Maps, Experience Builder use. It's a very common scenario. When you do this, there's two types of information that you may need to pass from REST.js to the ArcGIS API for JavaScript. The first is data, right? If you fetched any items or fetched a web map, anything like that. And in this case, it's the JavaScript API helps us out here. All the classes, almost all of them, have something like from JSON. So you can just pass that into that from JSON method, and you'll get a new instance of that class. The other thing you might need to pass is the authenticated user information, the credentials. So if the user signed in using REST.js, and this is where REST.js provides some helpful function called session to credential. So there is a example in our demos repo. We're not going to run this example, but just to take a quick look at the code of how you do this, somewhere earlier in this application's lifecycle, we have signed in with REST.js, and we have a REST.js session. And then after we've lazy loaded the ArcGIS API for JavaScript, and we're ready to load a web map, we in addition to requiring the map view and the web map classes, we are also going to require the identity manager class and call registers token with the session.to credential. And that's going to hydrate a new credential inside of the ArcGIS API for JavaScript. So now when this code tries to access this private web map, it'll be able to. Okay, I'm going to shift gears here and talk about Node. Obviously, with Node, instead of writing client-side browser applications, we're writing command line tools or maybe web servers. And if you think about how ArcGIS platform fits into that, let's revisit that Venn diagram that we talked about earlier and think of this as the total universe of operations you can do with the ArcGIS platform from JavaScript. And if you think about the ones that make sense in either a command line tool or on the server, it's really the ones that fit over here in this little section of overlap, right? We're not going to be rendering maps or anything that requires DOM like widgets. And so it's for this reason that we designed REST.js from the ground up to work just as well in Node as it should in the browser. The ArcGIS API for JavaScript, however, was not designed that way. It was designed initially as a client-side application, really focused on mapping and visualization. And it really hasn't been until the most recent version of the ArcGIS API for JavaScript 4.18 that you've been able to use it in Node at all. You can now use the ESM build in Node, although with some limitations, some caveats. The most obvious one being that you were restricted to doing the things that fall into that that same area of capabilities in the Venn diagram that's shared with REST.js. And so, but the real significant limitation is that currently with the ArcGIS API for JavaScript, you can't make authenticated requests. So it's probably not worth it. It's really, I think of this more as a happy accident of their effort to modernize the API. Again, it hasn't been designed to work in Node. One thing I will mention, however, that you can do with the ArcGIS API for JavaScript and Node that you can't with REST.js is that you can actually use the geometry engine. And this is pretty cool. This is something that, if you have this workflow, this might be something worth checking out. There's a sample here on the JSAPI resources GitHub repository, and then I've got a link here to a blog post that talks about using the ArcGIS API for JavaScript in Node. Well, let's get back to writing command line tools with ArcGIS REST JS. Let's see what that looks like. And, we'll start with a scenario that all of us as developers should be able to appreciate. As you're working on things, sometimes you don't always get it right the first time. And if you're doing CRUD operations, you might end up leaving around a bunch of trash in your ArcGIS Online org, items that you created that are half-baked or are invalid, never got deleted or half deleted, incorrupt, that sort of thing. And, it's every now and then we need to do housekeeping to clean this kind of stuff up. And no one wants to log into ArcGIS Online and find these things. We want to make it easier on ourselves and be able to do it from the command line where we are, writing our code. So inside of the ArcGIS REST GitHub repository, we've got an example called Node CLI Item Management. And this is pretty cool. What it does is it prompts you for a username and password, and then it'll prompt you for some search criteria to find items you want to delete in your that you own. And then it'll after you fill in the criteria, it'll list those out, and you can sort of go through each, tab through each, and decide whether or not you want to delete it. So this is a pretty cool example, but as developers, sometimes we want to really automate the heck out of this, and we want to burn everything with fire. So I'm going to show you some code right now that will do this, that will just run through an org and destroy everything that meets certain criteria. I'm showing it to you with a caveat that you should not run this code. The reason I'm showing it to you is because it's a little bit easier to understand than the example there in the repo. That example, a lot of the code ends up being used just to generate those prompts. There's really not much code involved in deleting the items. So this is a better example, but if you pull it and run it, it will delete things in your org and you will regret it. This example is not under the REST.js repository. It's under Dave's own personal GitHub repository. The name of the repo is called org cleaner. And we're just going to dive into the index code. Whenever you're working with REST.js in Node, one of the first things you have to do is bring in polyfills for fetch and form data. And this is because these are globals that Fetch sort of expects to exist, or that REST.js expects to exist, and they don't exist in the Node environment. But that's one of the only real caveats. Here are all the pieces of the API from REST.js packages that we're going to use. Mainly, we're working with the portal package to, to search for items and then delete them. We are going to be using, in this particular example, one thing that you can do is pretty common with CLI tools, is that we're going to be using a user session tied to a named user for the authentication of this. And in order to prevent the username and password from coming into the code, we're using the .env environment files. We're storing them there and reading them from that, so that they don't end up as something that leaks your password here. So one of the first things we do is just read those in from the environment file and set up a new user session, and then we're going to pass that user session to all the functions below. So let's take a look at one of those functions. This one is for removing survey 123 forms that you've created, and it takes in that authentication. It's going to build a query string to find all the survey 123 forms that you own that have it's also filtered to a particular type keyword, but it's going to use the username from the user session and build up that query parameters. It's going to run the search items function from REST.js, and then take the response that comes back and map over the results and send each result to the delete form function. So pretty straightforward stuff. And that's the kind of work you would do with pretty typical of the work you would do with the CLI. Again, use that code as a reference, don't run it. Let's talk about writing a Node server and how you could use REST.js in a Node server. The real question here is, how do we do authentication? The work of whatever you're going to do on the server with querying items and all that works the same as in a CLI or in the browser, but authentication we need to do a little bit differently. We can't just read in a single username from an environment file and use that for all the different users that might request to our server. So in fact, we've got an example in the GitHub repository that shows how to use the OAuth workflow from a server in a way that you can get a user's you can have access to a user's credentials on the server to perform operations on their behalf. So this demo uses an Express as the web server, and it's under the demos Express folder. And we're going to take a look here real quick at how the application works. So when you visit the application, when you first visit the application, if you haven't signed in, it's going to just ask you to visit the authorize page. When you do that, the authorize route redirects you to OAuth. So this is as we've seen before with client-side OAuth. And once you've signed in over there, and then the portal is going to send you back to our application, to the authenticate route, and it's going to pass in this code here in the query string, and then the server is going to be able to use that code to instantiate a new session. Now, in this case, it's not doing anything else with the session other than to render the token on the screen just to demonstrate that we've got it. So let's look at the code for this here. The whole server is only 33 lines of code, and it starts off the same way that our CLI did. We're bringing in those the fetch and form data polyfills that we need, and then we're setting up an Express app as normal and pulling in a user session. Again, in this case, the only thing this sample is using is a user session. And there's those two routes. So the authorize route, this is going to call the user session authorize function. Now, this is different than client-side OAuth. This function is meant to be used in a server, and all it does is is redirect. It sends a response redirect header to the client to send them to the server, to send them to the portal OAuth login page. And then that login page again sends them back to this authenticate route. And again, we're going to pull out that the authorization code from the query string, and we're going to use this user session exchange authorization code to initiate a new session. And again, as I said here, we're only, in this case, all we do is show the token to the user here, but this is where you could then take that session and go and do other things on that user's behalf. So this is a great demo to look at when you're just trying to get started understanding that server-side OAuth workflow. We're going to look at one more demo from the repository. This one is using Sapper. Sapper, if you're not familiar with it, it spins up a web server that renders pages in using the Svelte JavaScript framework. And to understand what this server is doing, we'll just take a look at it directly. It really just picks up where the last demo left off. So again, if you're not signed in at first, it's going to take you to that portal sign-in page. You'll be redirected back. Everything up to this point has been the same as the previous example, except instead of just showing the token here, it used that session that it created on the server to go fetch the web maps that you owned. And you can see here that these were, if we look at the source of this page, this was actually all rendered on the server. So the server fetched the items and then rendered out the links here. And if you link to any one of these, it's going to take you to a page where it lazy loads the ArcGIS API for JavaScript and uses that to render the web map as well as show you a bunch of information about the web map. The premise of this is that it's for checking the status of web maps. And you can see that this is a private web map. So the credentials have been passed from the server to the client and handed over to the ArcGIS API using that user session to credential. So this example really brings it all together. We're not going to have time to look at the code of this example. It is more involved. It's really the culmination of everything that we've looked at up to this point. So with that, you should have the idea by now that your one-stop shop for digging deeper from all the topics we discussed today is the REST.js GitHub repository. There's a link from that repository to the documentation pages, which is right here as well. On behalf of Dave and myself, I would like to thank you all for spending your time with us today. And we'd really appreciate it if you could take just a couple of more moments to fill out the survey that's linked to in the description below. Your feedback is really important to us. Thanks again.
Everyone, thank you so much for joining us for this session. My name is Andrew Tate, and I'll kind of be the moderator today, shunting questions off to our subject matter experts here, Dave Bowman and Tom Wason. So let's get started. First question I wanted to ask from this list on Slido, and do feel free to keep asking questions on the Slido presentation as we talk about them if there's something you'd like addressed. So first question for Dave. Can you get usage statistics for portal items?
So I assume, and start off by saying that every item has like a view count on it. So you can definitely get that because you can get an item. If you're referring to the statistical usage information that you get inside the Home app on the status tab, under there, we currently don't have any wrapper functions over the actual portal, the endpoint, which is /portal/usage. But you can watch the requests that are going on inside the Home app and basically recreate those things and use the requests function that's part of ArcGIS REST. And that will correctly attach in all of your session, user session stuff, put the token on the request, so on and so forth. As well as parse the response. And if you get weird errors out of the platform, it'll turn those into exceptions for you. So the quick answer, we don't have anything a function that specifically does that, but you can certainly structure a request, compute the URL, watch the requests that are going on the home app, and get the same information.
Awesome, thanks, Dave. Okay, Tom, question for you. Anonymous says it's a difference between 260 kilobytes versus 11 kilobytes in a JavaScript library loading. But how practically does that matter? Any scenario where 260 kilobytes loading is a concern?
Yeah, and it really depends on your application. It may not for your application, but there was another response in the questions there where someone pointed out a scenario where it definitely makes a big difference to them, and that is from someone named Dan. And I'll just go ahead and read that, where it says, I work in a remote area where mobile data is very weak and limited. I pay per megabyte of data. So 260 versus 11K is a 20 times savings. This makes a huge difference for me. Thanks for the efficiency. So that's, clearly one area when people are paying for the data. But the area that I typically think of is when if your users are heavily mobile and they have low bandwidth scenarios. If you're deploying an application to parts of the world where they don't have great mobile data service, it can be that every byte counts, but that may not be the scenario with your application. So it really depends. It's how important it is. It just depends on your application.
Awesome, thanks, Tom. Okay, question for you, Dave. Does ArcGIS REST JS work with ArcGIS Enterprise?
Yes, it does. It's uses exactly the same code, and we use it all the time. So when you deploy enterprise sites for ArcGIS Enterprise and the Hub product, it's the exact same code. So yeah, it works fine with Enterprise.
Awesome. So for you, Tom, we have a question from JS. Does your REST API allow importing data or create hosted layer so that they can dynamically add things in their ArcGIS platform dashboard, basically managing layers, maps, etc.?
Yeah, we have a package called REST.js Service Admin, and that has some very limited functionality for creating new feature services and updating the service definitions of those. I included a link to our documentation for that package in the response to his question. But if you just go to the REST.js documentation, look at the service admin package, you'll see what's there. Obviously, there's a lot more that could be added, as Dave said, with the usage. Just because we don't have a function that wraps a given endpoint of the REST API doesn't mean that you couldn't just use the low-level request function to interact with that API yourself. And ideally, if it's working out, submit a pull request with the function that was missing.
Yeah, great. And that kind of leads into the next question for Dave from the same participant. Is this some kind of SDK around a REST API? Do you have any documentation around the REST API if I were to implement any of this in any other language?
Yes, that's exactly what it is. This library is just a native JavaScript and friendly to use wrapper over the ArcGIS portal REST API. So if you go to developers.arcgis.com, that's where all the documentation is. That's officially provided by Esri for all the different API endpoints and what their parameters are. The other thing you can do is literally look in the source code of this library, because as Tom alluded to, for the most part, these requests are, when you use REST JS, right, these packages, it's just constructing a URL and sending a payload forward. So the actual source code itself is really, I think, straightforward if you wanted to re-implement this in something else. Erlang, I mean, we already have a Python API, there are .NET APIs, so on and so forth. So, if it's something that we don't already have, you can certainly use it from anything that can make a REST, an HTTP request, you can do it, so.
Awesome. One more question for you, Dave. And this is from an anonymous user kind of talking about authentication, it sounds like. They ask, can you use an API key with Node as a way to get around exposing your API key on the front end?
So this would be talking about the newer geo services stuff that just came out with version 3 and a release of ArcGIS platform. I believe that you can do that, right? Any place that you want to use your key to go and run things, you can go and either have that called from your browser or you can do it in the back end. And I think as far as Esri is concerned, you're sending a request that has a token associated with a key, so we're good. Tom, I don't know if you have any other info. I haven't seen anything around that, but I don't think there'd be any reason it wouldn't work.
Yeah, it should in theory. I haven't done it myself, but I'm almost certain it does. I was actually trying to look up there's another session that would cover that this week, and I was trying to look that up to see if it was on there. But if you look for the other REST.js session this week, they'll be talking all about that type of authentication.
Thank you. And Tom, one for you from Dan. Can REST.js be used to both change owners of content, for example, when one employee replaces another in an organization?
That's a good question. We have an update item method, and you could certainly call that in a loop. And I believe that you can set the owner with that. I'm not sure if Dave knows if there's any funkiness around that on the REST API level, but if it's as simple as changing the owner, then with an update item, then it's probably not. There might be a separate API method for that.
Right, and I think these, the underlying API has different rules based on who you are doing this as. So it may well be that if you authenticate as a full org admin, and then you iterate over these items and you set the owner to something else, the backing API may allow that. I don't know exactly how to do that at the API level, but I mean, worst case scenario, if there's some other endpoint that's needed, again, the request is the easiest way to just, you can go and use REST.js to go get all the items you want to work with, and then write a singular function that just, change owner on item or whatever, and it calls the other endpoint that's going to allow you to do it. So you could write the vast majority using the coarse grained functions that we already have, and you may have to write your own function that calls a specific endpoint if that's not already covered. And as Tom said, if you do it and it works, submit a PR, because we're always looking to grow this as soon as people touch new areas of the underlying REST API.
Awesome. One for you, Tom. Can you use REST.js to identify public services that others host, which you are referencing in web mapping applications and which are like down?
Sorry, could you read the question again? I'm just trying to.
No, that's fine. Yeah. I think they're asking about if you have a web mapping application that references some service, could you use this to check if that service is running or if it's down, or
yes,
the status?
There is a function in the feature layer, assuming you're talking about feature layers services, but there is a function there that it gets the service info, and you could use that. You could also, for things that are not feature layers, you can make a request with the request method to do that. Yep.
Cool. Well, I think that's about all we have time for. But thank you, everyone, for attending this session. And thank you, of course, Dave and Tom, for putting together such an awesome presentation. It's an exciting library and with an exciting future. So thank you.